Well, first of all, I would like to welcome everyone to this our second webinar of this 2024. Our previous webinar was about safety and vacuum systems for additive manufacturing facilities. And in this opportunity, we are very happy to host our friends of Farsoon Technologies, who are the experts on additive manufacturing of plastics and metals. So, well, first of all, I would like to introduce you to my colleague, Ray. He is here. He will be introducing to you about the flight technology and the 403P 3D printer by Farsoon. But first, I will quickly start by introducing briefly to our company. Well, first of all, my name is Harry. I am additive manufacturing engineer, and I dedicate to business development at Additive Plus. We are an additive manufacturing company based in California, and we dedicate not only to additive manufacturing, but also we provide atomizing solutions for laboratory. We work with custom alloys for metal additive manufacturing, and also we provide 3D printing services and all the technology that is required for additive manufacturing ecosystems. So to speak very briefly about us, we have been around 10 years in the additive manufacturing area, and we work a lot with academic institutions, with universities, national laboratories, and also aerospace, automotive industry. We have offices in Europe and the USA with dozens of machines installed all around the world. And we are actively working in many research and developments, additive manufacturing projects. We proudly represent, as well as Farsoon, 3D Lab ATO technologies for metal atomization, robots for FFF printing of PIC, ULTEM, and other materials, 3D Ceram for advanced ceramic material printing, Nexa 3D for ultra-fast 3D printing, Kings 3D for ultra extra large additive manufacturing technologies in resin and FGM, Delphin for vacuum systems, and Shining for scanners. We offer complete 3D printing solutions for every industry. So at the end of the presentation, we will be hearing and answering your questions. And also you can reach out to us or to my colleagues, Ashken email. So you can also reach out with any questions or inquiries about the technology we work with. So thank you very much for your patience during this quick introduction to Additive Plus. I would like to concede the word to my colleague, Ray. So thank you very much for joining us today, Ray. Ray is the application engineer of Farsoon, and he will give us today with he will help us today with a very nice presentation about flight technology. Hello, Ray.
Hey, Harry. Thank you. Good morning, everyone. First off, I just want to say thank you for attending today's live webinar. We're going to be exploring next level productivity using Farsoon's flight technology, presented by Additive Plus and Farsoon Technologies. So as Harry mentioned, my name is Ray Jones. I'm a polymer application specialist from Farsoon Technologies, based here in Austin, Texas. I'm excited to be here today to share with everyone our innovative flight technology solution that offers many specialized advantages that open brand new possibilities for functional in-use applications in automotive, healthcare, molds, tooling, and more. So let's just take a quick look at our agenda for today. First, we'll learn the basics, who Farsoon is, what materials we offer, as well as our industry partners and the key differences between fiber and standard CO2 SLS systems. Then we'll dive a little deeper into our flight systems and the opportunities that they unlock. And then to wrap up today's webinar, we'll take a look at a couple of Farsoon customer success stories using our flight technology. So Farsoon globally has grown exponentially in the last year as we've broken ground on our new headquarters offices and a new material factory, as well as hitting the 1,000 mark for systems sold around the world. Farsoon Americas, which is located in Austin, Texas, offers a dedicated local service team and inventory with key machine components sourced in the US. Farsoon Americas also offers a strong technical and application support team to assist customers on site in machine operation and material development, or remote from our Austin office. Over 10 years of technology innovation, Farsoon has developed a comprehensive polymer machine portfolio, which features a wide range of build envelope and temperature capabilities that suits many industry applications, from material development and series production to large-scale parts and continuous manufacturing. In 2019, we announced our biggest technology innovation with our flight technology by replacing the CO2 laser, which is traditionally found in SLS systems, with a fiber laser. This offers high-speed production and fine detail feature options to Farsoon's SLS systems. Looking at our polymer system portfolio, we can see that Farsoon offers a variety of options based on customer needs and budget. We offer a variety of build volumes from 20-liter small batch production and material development systems to 72-liter serial production systems to 225-liter oversized part and mass production systems. Max processing temperatures ranging anywhere from 190 to 280 degrees Celsius. Our customers can really choose and fit a machine to their specific needs and applications. Farsoon believes in an open material and platform environment. What this really means is that while Farsoon does manufacture our own PA12, both neat and filled variants, as well as a PA6 glass filled material, we partner with some of the industry's largest material manufacturers to help fill the gaps. This offers our material portfolio from base PA12 materials to TPU and TPC, PA11, both neat and filled variants, polypropylene, PK5000, ESD materials, and many more. We have ready-to-go material parameter files for all of our partner materials, as well as processing assistance if needed. Additionally, as part of our open material platform philosophy, we open several key parameter values to the end user to fully assist in material processability. So comparing CO2 laser and fiber laser systems, we can see a couple of key differences. The first key difference is laser beam spot size. Traditionally, CO2 SLS systems use a laser with a spot size anywhere between 400 and 500 microns. This usually restricts our minimum feature size to about 1 millimeter, or about twice the size of the laser spot size. We can see though with a fiber laser, we can get down to around 100 microns in the contour or outline pass to get real fine feature details around 0.3 millimeters. We are also able to open the fill pass to 1,000 microns, which greatly decreases build times. The second key difference is laser power. The standard operating range of CO2 lasers is usually around 30 to 120 watts. So fiber lasers, which are traditionally used in metal laser powder bed fusion systems, because of their more dynamic power range, can access wattages between 300 and 500. This gives us not only overhead on material processing ability, as some materials may need more laser energy at the bed than others, but this also unlocks a significant increase in scan speeds from 10 meters per second on the low end to 20 meters a second. The last key difference between CO2 and fiber lasers is their average lifespan and operational stability. So on average, a CO2 laser has a lifespan of approximately 12,000 hours, or roughly between 2 to 3 years of operational use, depending on power usage. Power stability on the laser, how much it drifts during operation, can reach upwards of plus or minus 6% during extended continuous usage. On the other hand, a fiber laser, because of its unique construction, has an average lifespan of about 100,000 hours or about 10 years. This significantly increases the value of the machine and reduces maintenance and replacement costs of multiple CO2 lasers over the same period of time. So using a fiber laser unlocks more laser power, which allows us to more easily process higher tier engineering grade materials. Traditionally, to process materials like PA6 or PA66 or PEC, which need higher energy densities at the part bed, a double fill scan would be needed, as most CO2 lasers can only safely reach about 100 or 120 watts on a single pass. So this primarily increases build time and laser life usage. With a max laser wattage of 300 watts on our dual flight laser system or 500 watts on our single laser flight system, we can process these materials in a single scan at a much higher laser wattage. This can potentially cut build times by 50% and also increases laser component life because there's less stress on the laser components. So what materials can the end user of our flight systems expect to use? As we can see, as of right now, there's an extensive list of materials ranging from base PA12 to PA6, PK, which is a polyketone material, polypropylene, PA11, neat, ESD, and carbon filled, and some gray and black TPUs. As you've probably noticed from this list, there's one common theme of all these materials, and they're all black or dark gray in appearance. It's because the wavelength of the fiber laser is only able to transfer its energy to dark materials. White materials kind of act like a mirror of sorts. They reflect the laser away from the part bed. That being said, there is some amazing work being done by some of our material partners to add additives to lighter materials to help aid in energy absorption so that we are able to process at a much wider range, both white and dark materials in our flight systems. So kind of looking at some material processability issues with CO2, traditional SLS technologies. One of the biggest obstacles to processing TPU with a CO2 laser is the amount of smoke and particulate that it produces during the sintering process. This smoke and off gas finds its way to the laser window, where it reduces laser power through the laser window at the part bed. So if you start at 40 watts, after 3 or 4 hours of the sintering process with all that smoke and particulate sticking to the laser window, you might actually be only getting 20 or 15 watts at the part bed. So this requires either shorter builds to avoid the smoke buildup on the laser window, or manually going in and editing the laser wattage parameters through the build process. Another obstacle is the way that the material absorbs the laser energy, which results in slow sintering speeds and low productivity. So I'm going to play a short video here of our flight system processing or TPU material. The first thing that we can see is that there is no smoke generation while using the fiber lasers. This keeps the laser window clean, which allows us to complete full Z-height builds with little to no operator interaction. The way that the TPU material absorbs the energy from the laser, the fiber laser also allows us to utilize the max scan speeds of our flight systems to increase productivity and machine turnaround. So one of the better use cases for TPU in our flight systems is shoe soles. It's kind of the rage right now in SLS. You've probably been to Dick's or Academy or any of these sporting goods stores, and you can see, the Adidas or Under Armour, they have this lattice outer sole. With the flight system, we were able to pack the build envelope with 50 shoe soles, and we were able to accomplish a full build in 17 hours. Which, if anyone has ever processed lattice structures in SLS, can attest to the long layer times just because of the complexity of the lattice designs. There's a lot of laser jumps. So not only were we able to take advantage of the ease of processability with fiber lasers, but also the increased scan speeds. So to take a look at our Flight 403 production platform, the 403 is a bottom-fed single or dual laser SLS system with a build envelope of 400 by 400 by 450 millimeters, and a max process chamber temperature of 220 degrees Celsius. The feature that makes this system unique is that it is equipped with removable feed and build cartridges. This allows for faster machine turnover compared to a lot of other SLS options, as operators can stand or stage next build ready cartridges and hot swap them with depleted feed cartridges and completed build cartridges. You can see number one is our feed cartridge, number two is our build cartridge. So once a build is completed, we can remove those and insert a filled feed cartridge and an empty build cartridge into the machine, load up our build and push go. As we move right, we can see some accessories developed by Farsoon to increase machine turnover and productivity. Our external cooling box and cooling station greatly decrease the cooling times of completed builds in a user-controlled inert environment. This not only increases productivity, but also ensures material and part properties. Some materials like your PA6 materials, your high temp processing materials, naturally take longer to cool down. One, because they are processing at a higher temperature, but also because we really need to preserve those mechanical properties, whether they be tensile strength, elongation. So being able to take that build out and being able to put it in an inert environment to preserve those mechanical properties is really important for the in-use application of those parts. We've also developed and will soon release a integrated closed loop breakout, sieve, and mixed powder management system. This is number 5 on the right-hand side. The system has the capability to sieve and mix large volumes of material to then be used in subsequent builds that use the same type of material. It is a closed loop system, so we do recommend having it primarily for one material, 2 at max. So I'm going to play this video right here. This really showcases and drives home what I've been discussing up to this point, comparing CO2 to flight. So our CO2 system is on the left corner, our single fiber laser system is the right corner, and middle bottom is our dual fiber laser system. We can see that our dual laser system is able to scan a layer of 20 parts in 26 seconds. The CO2 system can scan 5 parts in the same time frame. And while the single fiber laser system was able to scan the outline of all 20 parts, it was only able to scan 8 full parts. So Farsoon manufactures the industry's largest SLS platform system equipped with either 2 or 4 300-watt fiber lasers. The 1001 offers a build envelope measuring 1000 by 500 by 450 millimeters, which is 3 times that of our 403 system. The 1001 platform is a top feed side loading conveyor based system that is ideal for either producing large scale parts that traditionally would have to be produced in multiple parts and joined together in post processing, or large scale production runs of small to medium sized parts. Additionally, the 1001 can be equipped with an optional cool down station that actively cools one build while a second build is in the build process, so actively sintering. This cool down station uses an active nitrogen supply to cool builds in a closed inert environment. So to put into perspective the level of productivity that our flight systems offer over traditional SLS technologies or other additive technologies such as MJF, we put together a full pack-out build of the same standard size parts and an MJF build envelope, our standard CO2 403 system, our single and dual laser flight 403 systems, and then our dual and quad laser 1001 flight systems. So as you can see from the start, our 403 system has an advantage being able to fit almost 100 more parts into its build area. Looking at our standard CO2 laser system, the HT403, which is comparable to most mid-size SLS systems currently on the market, We can see that although, yes, we are able to nest 266 parts into the build envelope, we are looking at a 25-hour build, which is not quite ideal. And that's where our single flight laser system comes into play. We're able to cut down the build time to a little over 16 hours for 266 parts. That gives us 1.5 times the productivity yield in just about the same amount of time as the MJF system. Moving to our dual laser flight system, we can see that we can cut down that build time even further to a mere 10 hours, giving us 2.5 times the productivity yield. That's 266 parts in 10 hours compared to 168 parts in 13 hours. Moving on to our dual fiber laser large platform 1001 system, we can see that the larger build envelope allows us to nest 784 parts and complete a build within 18 hours for productivity yield of 4 times that of some of our competitors or even our own CO2 machines. Finally, to round out our system comparison, I want to take a look at our quad laser 1001 system. As we can see, we're able to match that 13-hour build time and produce 784 parts. That's almost 5 times the amount of parts built in the same 13-hour time frame advertised by some of our competitors. So I want to take a look at a couple customer use cases using our flight technology and some of our materials that have been developed specifically for our flight systems. So the first customer success story I want to take a look at is this 3-piece molded fiber tooling set. This was created in our FS3201 material using the dual laser 403 flight system. The customer was able to custom design a cavity mold as one piece to avoid sectioning and machining the part in a traditionally manufactured type environment. Utilizing the flight system fine detail capabilities, the customer was then able to design a mesh screen mold insert that with detailed mesh density and wall thickness. Finally, utilizing the material's mechanical strength, the customer was able to create the final component, the mold body, that was used to apply pressure to form the desired molded part. Being able to design the exact part that they needed, the customer achieved an accelerated design to production cycle and reduced manufacturing cost by 97%. Next, I want to highlight 2 different automotive applications using our PA6 glass fill material. The first is an NVH cover printed in our 6140 GF, which is our glass filled PA6, using the Flight 403 system. This customer was able to create a unique sound dampening design to reduce structural and ambient noise with the added bonus of structural strength and impact resistance, which are both important components to under the hood applications. The second application is an indoor speaker mounting bracket, also printed in our PA6 glass fill material. Being able to present the full bracket as one part greatly reduced lead times and material and labor costs, while also taking advantage of the structural strength of the design being one complete piece instead of joining 2 or 3 pieces together. One of the strengths of SLS is being able to design, custom parts for your in-use applications. One of my favorite applications is this automotive headlight housing and assembly printed in our 3201 material. This customer had a unique design in mind and was able to print the housing and assembly as one part, post-process the part and install it directly into their car. Over traditional manufacturing means, this process saved in the production process and at a cost reduction of 98%. The last set of automotive customer applications I want to kind of showcase are ducts and airflow pipes. Our first application is a complex multi-channel air duct printed in our 3201 material. Utilizing the strength of our material, the customer was able to print this part with improved structural integrity and in one piece over to traditional manufacturing methods. The second air duct needed high temperature and corrosion resistant properties that our 6140 PA6 glass filled material excels in. This customer was able to print this custom fitted part in the 403 utilizing an engineer grade material with ease. And the last application is a multi-directional airflow pipe, which was printed on our 6140 PA6 material. This customer was able to design a part with an integrated structural design using material that met their tensile strength requirements and utilizing the fiber laser system. They were able to achieve their accuracy and tolerance specifications. And last customer application I want to showcase is in healthcare with a mid-layer orthotic insole and knee brace. Customizability using SLS technology is a perfect fit for shoe wear, as I mentioned previously, especially with sole correction and arch support. Being able to scan a patient's foot and print a tailored insole is key. Using a strong but flexible material like a 3201 allows the wearer to use this part on a daily basis without any show of wear or tear or fear of the part breaking down in everyday use. Same can be said for knee braces. They can be fully customized for each individual patient's needs. Using BASF's PA11 material in conjunction with our Flight Technology, the customer was able to create a lightweight design that was comfortable for the user and was also breathable, utilizing BASF's material properties and capabilities. So that includes our presentation on exploring next level productivity with Flight Technology. If you're going to be at AMA next month, feel free to stop by our booth to further discuss our flight systems or any of our other industry leading solutions. We'll be happy to sit you down and talk your ear off about all of our products. So thank you for attending this morning. Now we'll be open to any questions that anyone may have.
Thank you very much for your presentation, Ray. It was very interesting to see how you can improve the productivity using the flight technology. In case someone from our attendees has any question, you can just unmute yourselves and make the question, or you can send it to our chat. In the meantime, Ray, I would like to ask you a very quick question about the flight technology. So you mentioned that flight technology can exceed in the speed of printing to CO2 technology. But is there any other advantages that you can share with us, like in a brief summary for us?
Yeah, so scan speed is the main draw, the attraction for this technology, but feature size too. We can get down to 0.3 millimeters in feature size and wall thickness, which is less than half of what we can get in our CO2 technologies. So fine feature details is really key. Especially in some smaller type applications, small gears, electrical components, fuse boxes, things like that, where you still need mechanical strength, but you also need fine feature detail.
Great. Thank you very much. Okay. From our attendees, we have any new questions?
I have one question for you, Ray. On the white development, do you have any time frame on that?
Currently, no. I wish I did. I know that it is currently in development. If you want to send either myself or Harry an email, is there any particular material that you're interested in, or just kind of full spectrum?
Probably like PA12 with any kind of blends to it.
Okay.
And maybe 11s as well.
Okay. Yeah, I can definitely when information starts becoming more public, let's say, I would definitely be more than willing to share some information with you.
I also have a question about the white powder. So I know that usually carbon black is used to stain the powder to have a black or gray powder. So clear additives for the fiber laser are much more expensive than carbon black. So this was up to now usually the problem that everybody uses carbon black. So, and I have another question about the PA6 material. Is that a fiber filled material or is it a pearl? So PA6 with glass pearls or with glass fibers?
Yes, the PA6 is glass fiber filled. It's a 40-60 blend.
Is it a dry blend?
Yes.
Okay, so refresh rate is you know the refresh rate, or
we usually try to aim between 40 and 50% new material. Obviously, our end users can play around with refresh rate depending on what type of mechanical properties they're looking for. But we've developed some mixing or powder management systems, our PMS system. We've developed that system to utilize high-speed mixing to preserve or extend the life of used materials.
okay.
Okay, thank you very much, Bern and team. Do we have any more questions? I may have one more question about what other solutions do Farsoon provide to the in the market apart from plastics technologies.
So we do offer metals machines as well. We have a full line of metal laser powder bed fusion machines. Kind of mirroring our polymer systems, we have small machines for more material development work, and then we have large two-story machines that are bigger than my house for like rocket engines, large scale manufacturing parts. So we do offer polymer and metals, but we do offer, again, our external cooling stations. We sell breakout stations, mixers, our powder management system. So we kind of offer, and of course our own materials as well. We like I said, we do manufacture a lot of our own materials that we offer at a competitive price compared to a lot of our competitors. So we try to have our hands as many honeypots as we can, per se, to really offer any type of application solution to our customers.
Great. So thank you very much, Ray, for your presentation and also for responding our questions. And I would like to finish this webinar with an invitation, so you can visit our YouTube channel where we will be where we have our previous webinar recordings. We had we previously host webinars about ceramics technologies, vacuum systems, and our next webinar will be about also ceramic technologies, and the next one will be about a large format printing with SLA. So you are all invited, and please keep tuned with our social media where we'll be posting about our next and upcoming events. So thank you very much for today, and have a great week ahead to everyone.
Thank you, everyone.